on behalf of India Energy Week 2024 edition 2, I would like to extend a warm welcome to each one of you present here. At the outset, I am very much pleased and honored to be part of the chairing the session today, along with my co-chair, Mr. Sanjeev Kulkarni. Before proceeding, I would like to introduce myself. I am Karunanidhi TV, coming from Bharat Petroleum Corporation Limited. I have been with BPCL for last 3 decades. Currently, I am part of supply chain optimization at corporate office, Mumbai. I request Mr. Sanjeev to introduce yourself. Come.
Thanks, Karunanidhi, and warm welcome to you all again for this session. My name is Sanjeev Kulkarni. I am heading the engineering for India, Middle East, Africa for the one of the division called Energy Industries for ABB.
I would like to indicate the rules for benefit of all of us here. Each speaker will be given 14 minutes for their respective presentation. There are 4 speakers. Question answers will be taken at the end of all the presentations. So I request all the audience to hold your clarifications and questions till the end of all the presentations. We will try to conclude the session on time. The topic is operational excellence. The title of the category of operational excellence is achieving operational excellence with intelligent automation and technology. Operational excellence is pursuit of efficiency, effectiveness, and continuous operational improvements in any facets of operation in any organization. From streamlining workflow to the maximizing the productivity, from minimizing the waste to maximizing the customer satisfaction, operation excellence will come as a cornerstone for sustainable growth as well as success. In the next 4 sessions, there are going to be various aspects of operational excellence, including best practices, emerging trends, real-time case studies. Our goal is to gain insights, exchanging ideas, and inspire one another for elevating our operational excellence to the new heights. Without further ado, let us commence the session. Let us begin the session with a round of applause.
Okay, since already Karunanidhi has introduced the session as well as speakers, before begin, I thought it's better to have a few words about the importance of this session. Already, we all know that base operational excellence is something which most of the industries or organization embraces to achieve the best-in-class service or quality or productivity and other things. So one of the major factors in all these things is all around automation. And since we need to link this with the today's topic of intelligent automation, that's what I thought it's better to bring automation point in here. Even though the operational excellence covers the entire value chain of the manufacturing process, right from design engineering up to the sales and marketing, it covers all the points. But all along, automation is a major point. And with involvement or with enhancement in the technologies, even though the main goal of operational excellence remains the same, achieving the best in class, productivity or quality or service, only the levers keep changing. It's due to the technology enhancement. And as we see that digital technologies are enabling the automation to the next level, so mainly like AI, ML, all are the advanced analytics, all these things Are they going as a complementing to automation? That is how it is called intelligent automation, where you have one side you have the automation, you have complementing technologies together, mainly supporting organization to drive the automation excellence. So today we are going to have four good sessions. Obviously, I have seen the abstracts, and we are going to touch all the value chain of all the four areas where we see that how technology is supporting the development, how the technology is development is the remote operations, and also he is going to see a session on maintenance. So in that way, I think it's a good mix of all the different areas of the complete value chain of the manufacturing process. With that, I think we'll open the session with Arvind Bansal to start it. Please.
Good evening, everyone. So let me briefly introduce myself, although the introduction has already happened. So I'm Shailesh Bansal. I am with Lummus Technology for almost 10 years now. I started my career with Reliance, and I am a chemical engineer by background. Currently, I look after the business development under Lummus. So today, the topic which I'm going to cover is the digitalization tools for enhancing process stability and reliability of plant. So why I chose this topic, that everyone is talking about the operational excellence at the moment, right? So we are trying to get the best out of everything. But we also have to realize that yes, the operational excellence is very much important, but if the plant is not stable and reliable, all the added value which we are trying to achieve using the digital tools vanished in a moment if anything goes wrong in the plant. So how Lummus really can help use under their business unit, Lummus Digital, to achieving the plant stability and reliability, and to make sure that the plant is running up to the mark. And so before I move into the, just briefly on the agenda, I'm going to talk about the Lummus Digital business unit, which comes under Lummus Technology, where we handle the digital transformation of downstream oil and gas value chain. And the two specific topics, or the I'm going to cover, is performance monitoring and the communication platform. And the second one is one of the prescriptive reliability solution, which is digital process advisor. Now, starting with the brief introduction of Lummus Digital. So this is fairly a new business unit under Lummus. I would say almost 3 years into the industry already. This is a joint venture between Lummus Technology and TCG Digital. So briefly on Lummus Technology is a technology licensing company of almost 110, or now almost 115 years of legacy, with more than 170 licensing technologies in refining, petrochemicals, gasification, and polymer unit, and more than almost 2,500 operating units. Uh, then we have other joint ventures, CLG, Novolane, which also license other technology portfolios under the hydrocracking or the polymer units. And the second partner is for Lummus Digital is TCG Digital, who are in this space for more than 20 years of digital transformation, mostly focused on the airline industry, banking. So this Lummus Digital is a joint venture of best of both the worlds, where we are focused completely on the oil and gas downstream sector. So if I talk about Lummus Digital, so how we are different and how we really differentiate from others in the industry, or how do we really complement others in the industry, is mainly because one of the major reason is the Lummus's involvement in any of the development and implementation of any of the tools or the services which we implement. So this proprietary know-how of Lummus is very instrumental or very important in every aspect of services or the product which we deliver to our customers. Uh, Certainly, the second part which comes from TCG Digital is the AI-based data management platform, which is called MCube. So this MCube is a platform for us where we deploy our solutions, and this can be installed or implemented on cloud or on premises of any customer. So there is no restriction that it needs to be on cloud only. It can be into your system, into your premises, uh, to make sure that it is compliant with your data policies. Third important parameter or the strength for us is the hybrid model. So this is more like a first principle and data science. When I say first principle, it can be first principle kinetics, it can be the proprietary know-how of Lummus, which is an IP to us, the technology expertise of Lummus, and the data science aspect of TCG Digital. So this is more of a combination of best of both the companies. And pre-built portfolio, so we are mainly focused on the oil and gas downstream value chain, and that's why our products and services are also very much focused to the technologies which are licensed mainly by Lummus or open art in the industry. Now moving into the topic performance monitoring and communication platform. So when we say performance monitoring, very first question generally we get is performance monitoring. I mean, we don't see any specific value directly from the performance monitoring. So how it is different? So we already have a DCS system. How it really brings? So certainly, I mean, there is a DCS system. There is every KPI or the tag which you can look at. So how it is really going to impact the customer if we are talking about. So what we have here is the complement, the performance monitoring complemented with the communication platform. Now this so going into the detail of that, if you look at the sample dashboard, it talks about a lot of KPIs or the critical parameters of the unit. And there are many important critical KPIs which are directly accessible for the DCS, but then there are a lot of critical parameters which are important from the licenser's perspective or the Lummus perspective. So we are not limited only for tracking or monitoring the KPIs which are there only in the DCS. We use those, definitely use those important plant operating data to come up with the insights which are important from our perspective and how it basically affect the plant performance. Yeah. So if and how it is embedded with the communication platform is basically uh, any parameter, any parameter which is being tracked in using this performance monitoring dashboard system, it's basically linked with the communication platform. So if you look at this help icon, it allows you to basically generate your queries with respect to any performance KPI and let it float to the licenser. So this platform basically connects with connects the operator or the unit or the customer directly with the licenser. Why this is important and why it is different is right now I know that generally how people work on it is we if we have any queries, if we see that anything is going wrong, we contact the customer, we contact the licenser, we ask for the queries, raise the technical queries, and then we get response through the email chain, right? But let's suppose that the people are moving, because in any plant there is not a single person who will be running the plant throughout their plant life cycle. So what kind of database you have and how you are making sure that the communication is getting cascaded or flowing to any new person coming into the unit. So this platform allows you to generate these queries and let you connect with the customer with the licenser, and the licenser basically responds to your queries directly, let you help you to solve the issues, to solve any of the queries you might have with respect to the operations of the plant. But at the same time, it keeps the database of all the queries you have generated so far, and it is not lost in the inbox of your Outlook. So, and it is important because every year or maybe let's say every quarter, new people are coming into the unit. And if any similar situation happens, you do not want to waste your time to solve that similar issue if it is coming again in future. So this is more of a database which basically help you look at the problem which has already happened into your plant and let you solve it very actively. So you're not losing any time, because losing time is losing money in the industry, right? So and this is a searchable forum platform. So anything which has already happened, it let you search and let you see what has already happened and how we have solved it earlier. Now moving into the next product or the service, this is very much connected to what I spoke now, but this is an extended version of the communication platform. This is Digital Process Advisor. So now certainly we are there to help you as licensor in your plant operations to make sure that the plant is running very smoothly and up to the mark. But you need to be more accountable, or let's say that you need to be more independent in terms of operating your unit. So how can we help you make you more independent, and how we can help you basically learn from the experience, the industry experience of operating that unit. So this digital process advisor is basically nothing but the experience, Lummus's experience of all the operating units. So when I'm saying 25,000 operating units, so for any technology, Lummus certainly have experience of more than one commercial experience, how the unit has been operated, what kind of issues they have faced, right? So when we are talking about those issues, so one customer's experience for any issue which has happened in the plant is basically a lesson learned for another customer. So if you have already faced any issue and you know that we have already, so Lummus has seen those issues with the customer, and we have the database of all the commercial experiences. So what it really does, this digital process advisor basically let you look into that issue. So let's say that any KPI is going wrong out of the operating range, it let you see the possible reasons behind it and the corrective actions which can be taken to make sure that the unit is moving in the right direction, the operations are moving in the right direction. So what it really does, that let's say for a one particular example, in any product there is an off spec, or there is a contaminant which we are trying to restrict up to a certain range, but if it is going certain beyond limit, then it basically alerts you that okay, this parameter is going wrong or the off spec, you need to look into this, and then it basically generates some alerts and warning and let you see the possible reasons behind it, and how these reasons are coming from all experience of ours or Lummus's with other commercial experience of other units into the industry. So we are using that whole technology expertise or the operating experience to have this database in place for you to use as lessons learned from the industry. And once you know that okay, these are the possible reasons behind any issues in the plant, what are the possible corrective actions you can take? So this is more like a robotic guide for you. So you don't have any person sitting with you there to help you, but you already have a database which is kind of guiding you that these are the issues, these are the possible corrective actions, and once you take those corrective actions, then how you are moving in that direction. So it starts with, let's say that something is going wrong. So if left unmitigated, what are the possible consequences? And in order to mitigate those risks, then what are the possible corrective actions an operator need to take? And once those actions are taken, then what is the impact of that corrective action? As and when you implement those corrective actions, it basically reflects into your system and see that how your operations are changing. So what really goes behind this database is a decision tree. So this decision tree is basically a full exhaustive commercial experience we have with all our customers in different technologies, in different units. And it basically kind of use a decision metrics to come to basically identify the issues. And then from one issue, what are the possible reasons? If it goes into a certain direction, then what are the possible corrective actions? Uh, and uh, once it identifies the accuracy of those results and the parameters, then it basically recommends some corrective actions for you to take. So this is the decision metric which goes behind the database when it runs automatically into your system. Once uh, once the corrective actions are taken, and it is up into the certain operating range where you are safe, where there is no issues with the reliability and the stability of the plant, it then goes into the recommendation that there is no further action required from your end, and you are up to the mark. So it is happening in real time for each and every critical parameter which we have identified for your unit from our perspective, and definitely from your perspective, because there are certainly various parameters which are important from your perspective in terms of maintenance, in terms of process performance, and from our perspective in terms of design, and definitely the process performance of the unit. So this is what everything goes behind, and the two important aspect of uh, behind these two particular products is definitely leveraging the AI and data science capability of uh, TCG Digital, which basically looks after the data management, creating AI model for the process. So for the communication platform and the digital process advisor, the generative AI is being used for the overall development and implementation, and it goes behind the scene, which is not really a user interface for a customer. So it's the user interface which you see is very much user friendly because you don't want to get into the complication of how it works and what is happening at the back end. But it also allows you to see and kind of validate those kind of recommendations from your own experience. Then certainly leveraging the process expertise of Lummus Technology, and yeah, and defining the appropriate data segment. So ultimately it combines the hybrid AI technology with traditional process expertise to create a predictive solution to improve your plant performance. And to summarize the key takeaways of the product and the services which I'm talking about is to maximize the stability and reliability. One, for the performance monitoring solutions, certainly the improving the visibility of the plant performance from various other aspects which you are already doing. So what else we can bring into the picture? And the focused attention of the most important parameter. So you don't want to lose your attention to each and every parameter which are there in the plant. You want to have some focused attention on which are very important parameter. The communication platform is, again, it is keeping you connected with Lummus experts and the licensors into the unit, because they are also bringing in the additional expertise or the experience of other operating units into the industry. And prescriptive solution is, again, into this aspect, we are leveraging the technology expertise here, the know-how of the technologies and the operating experience, and kind of enables you to take the faster and the better decision making. So you are not losing any time, and hence you are not losing any money. And finally, the predictive solution, so it kind of deploy the AI data model to identify and prevent those upsets. So the digital process advisor uses that a lot, and kind of catch any small problem before they can make any larger impact. So this is more of a preventive and predictive solution which I have talked today. Thank you very much, and if you have any questions, I'm here to take that up. Thank you.
Thank you, Bansal. You have timely completed your presentation. The next presentation is by Mr. Shreyansh Upadhyay, Senior Manager, Business Strategy, Accenture Solutions Private Limited. I request Shreyansh, please come on to dais and proceed with your presentation.
Thank you, Mr. Karunanidhi and Mr. Kulkarni. It's an opportunity for me to speak in front of all of you on a very relevant and important topic. A quick background, I am Shreyansh Upadhyay, part of Accenture Strategy, and as Accenture Strategy, we consult a lot of energy clients, almost all the energy clients in India and globally, on pertaining issues of digital transformation, production excellence, business transformation. So we work on a variety of topics. Today, I'm going to speak about a little different topic. I mean, the key theme of today's session is operational excellence. I want to take operational excellence into production excellence, and that too in the upstream sector of India, because that has not been spoken too much about in the last few sessions. I'll talk about how upstream players in India should remove the bottlenecks using data and analytics in their production domain. And let me set some context that why is upstream so important. We all know India is third largest energy consumer. We plan to be the second largest energy consumer by 2030. We are almost growing at we are going at a phenomenal rate, and 25% of this energy is being supplied by crude oil. Now, out of this 25%, 80% of crude is being imported. And just to put a number in front of everyone, the annual import bill on import of crude to fund or to meet our energy demands is north of $100 billion. At the same time, to bring down this particular import bill, we are aiming to be producing more oil and gas, crude oil from India, so that we can ramp up the 20% demand that we are meeting today organically to 25% by 2030. This 5% jump, and also we are talking about that we'll become a gas economy, we'll increase the share of natural gas to 15% in the energy mix. To achieve all of this, these are all good mountainous targets, ambitions that we have taken. But to meet these targets, there are certain impediments. And the impediments in the upstream sector are mentioned over here. And I'll just quickly touch upon a few of them. The process is a lot manual these days. It's not scalable. We are having people who are going to the wells, to the fields, and getting data every day. The analysis itself is also happening through manual processes once in a day, once in a month. Metering is happening once in a fortnight. So with all of this, there are impediments. You'll not be able to identify where are the bottlenecks, and if you're not able to identify the bottlenecks, how can you imagine to remove them? So the solution that I'm going to speak, the way the process is being run in upstream sector, which is highly manual and also dependent on Excel sheets, various data silos, yeah, and hence, to solve this problem, we can talk about data and analytics. Yeah. So to solve this problem, we'll talk about how power of digital data analytics can be leveraged and production excellence can be achieved in upstream sector. So the solution to all these problems is real-time production monitoring, where the power of technologies like 4G, LTE, data analytics come together to achieve optimized performance or production performance in onshore and offshore fields. If you see key features of the solution, I mean, there are installation of sensors, there is installation of COTS application, creating enterprise hierarchy. So all of this come into play. There's a basically tiered structure which starts from sensors on the ground, which is communicating to the central database or let's say a central zone through 5G or LTE, where you deploy a PDMS solution, which is called Production Database Management System, which is basically storing all the historical data and the real-time data. You deploy some network models or COT applications, which will then churn data into analytical models, and then you develop some analytical workflows on top of it, which I'll subsequently talk about. The end benefit is to make the process more streamlined, achieve production uplift, which everybody wants to achieve, increase the margins, the revenues, and also to expand the margins, as I said. And also, to achieve the margins, we'll have to do it at a better cost by lesser involvement of manual labor, and then the processes which are manual, you save a lot on the costs as well. So this is a quick architectural diagram which talks about which are my source systems. So if you see on top, we have some operator rounds in which typically operator goes into the field, collects day-to-day data. All of this can be brought into a tab, which is again a digital technology, and you can get this data into the PDMS directly. The well test data, which is happening once a fortnight, can again be brought into your SAP, and from SAP it can be brought into your PDMS system. And similarly, your well reports, your events, your alarms, notifications, whichever are generated on the field in various source, can be brought into your PDMS system. And as I said, the most important part of it, which is the most basic layer as well, is your real-time data which is being generated by sensors. So yes, this initiative talks or calls for installation of sensors across the wellheads, which is one capital-heavy activity. Now, once these sensors are installed, they are feeding the performance of wells, equipment, vessels, and your process, separation facilities as well. In their real time, how are they performing into your PDMS? Now, PDMS is nothing but a historian, or you can call it as a real-time database management, or database system, which is storing these real-time and business data as well. On top of it, we have to develop well models and network models, and on the front end, we have visualization layer. Now, through this visualization layer, we can do a lot of things. So you see the top 4-5 elements functionalities like event management, surveillance, optimization opportunities, exception-based alarms and events. But the most important, see, these are all descriptive. This is okay. This is no new thing. The new thing where actually data part, analytics part kicks in is the last part, where you bring in the historical data analysis, develop AI ML models to achieve optimization of gas lift, of SRP, of virtual flow metering, of chemical spend, right? So all these analytics are possible where exactly you start saving cost and increase the production as well. So let me speak about a few of them. First one is virtual flow metering. Now, in case of virtual, what happens typically in a production context? The wells are producing, they feed into a test separator. Now, test separator is a huge vessel of physical infra which is used to measure the flow rate of a well. At best, you can measure a well's performance once in 2 months or once in a month. At best, once in a month, typically once in 2 months. So it's only at a frequency of 1 month or 2 months you get to know if the well is declining, producing water, producing sand, right? And then only you can take corrective actions. The problem can be solved if you have certain ways of measuring the flow rate, the three-phase flow rate, which is your oil, gas, and water, in real time. And this is achievable through virtual flow metering. Basically, it is AIML model which works on top of the typical physics-based first principle models and nodal models, which works on these models work on the real-time sensors like THP, CHP, and it also leverages the communication that is happening across, or the flow that is happening across the flow line. With this, we can achieve a production uplift, which has been a proven case study of 2 to 4% in any upstream well. It is a cost-effective and super scalable solution, and the well test accuracy has been proven to be north of 85%. And this will also help in reducing the well physical infra that I was talking about for well test. Ultimately, OPEX reduction is an added advantage. So this is one particular analytical model. I'll talk about a few more in subsequently. Second one is gas lift optimization. In any of the wells, if some of you know about the production, upstream production, the initial part is the wells are self-flowing, but subsequently the pressure or the reservoir pressure goes down, and we have to adopt some ways of artificial lift. Gas lift is one of the ways of lifting crude from the reservoir to the surface. Typically, we inject gas into the well to lift the gas, lift the crude oil or the natural gas again above the surface level. Typically, there's a gas injection happening, nobody is monitoring it, and this gas is the associated gas which is produced. To increase our dependence on gas, or let's say increasing the mix of gas, natural gas in our economy, we'll have to save this important gas, or let's say critical gas that is being produced, which is being brought to the surface at a cost. We should not waste it by injecting it again into the well. How can we achieve that? We can optimize the rate of gas injection which is going into the wells. Again, this is again done by these analytical models where you assess how much of gas is going in and what is the productivity it's leading into, right? What is the kind of pressure that is there at the well? What is the flow rate that we are achieving by how much of injectivity pressure that we are maintaining into these wells? So typically the four components of the solution are gas lift surveillance, where you identify that which of the gas lift wells are performing well or are not performing well. Those which are not performing well, you have to take corrective actions. So you diagnose. You diagnose if there's something wrong with the injectivity pressure, the volume that is being injected, the point at which the gas is being injected, and then you optimize, by carrying out VHP and IPR curve analysis. And ultimately, you can control at what pressure and at what frequency or what rate you want to inject the gas. So once you do this, ultimately you are saving on a very critical resource, which is natural gas, and also producing more from the wells which were not producing as high, which were requiring more gas injection. The benefits again is real-time monitoring of using wellhead sensors. Deferments are reduced because these wells are not going down. You are surveilling them as on a real-time basis, and the production from these wells is also increasing up. Most important of all, you are saving on the critical natural gas, which can be then sold or can be consumed in the market. The third important workflow is SRP performance. SRP stands for sucker rod pumps, which is artificial lift technology. In India, out of almost 10,000 which are onshore wells, 70% of them are SRP wells. These wells work, and these are the mostly onshore wells which are working on ground, and they are very distant in the field distributed. Nobody is monitoring them on real-time basis. Forget monitoring. If a well goes down, it is down, idly down for next 2 or 3 days, unless and until an operator goes and sees that the well is not working or the pump is not working. So first of all, we have to bring surveillance on these wells. This can be simply done by installing these position load sensors and wellhead sensors, which will tell that is the pump working well or not, and is the well producing at the right pressure and right flow or not. The moment the well is not producing or the pump is not working, there will be alarm that will be generated. And using these position rod sensors, position cell sensors, we can generate dyna cards, which is also in real time. So these dyna cards are very specific to a problem. Let's say that there's a rod breakdown, there is gas interference. So all these will lead to a very specific kind of dyna card diagrams. The system, the solution, can automatically tell you that this is the root cause of the problem and there is the problem lying, resolve it. It will help you to attend that problem in real time and attend to that particular well, which ideally would have been down for 2 days. You can bring down the downtime of that particular well to mere hours. And you can optimize the set points as well. The benefits, again, as I said, the capex involvement is lesser because these SRP wells are very capex heavy wells. Production uplift is there to the tune of 10%, which we have seen in case of onshore wells of Western Onshore in case of ONGC. And then there also, because of lesser manpower movement in the field, there is a control on the safety incidents also, which are pretty much evident. The fourth analytical workflow is about chemical analytics and optimization. This is applicable both to upstream as well as to downstream industry. Typically in upstream industry, there is a separation that happens of the emulsion that is being generated. So there is a demulsifier, there is a de-oiler as a chemical. What we have typically seen is there's a chemical injection skid lying somewhere in the remote area, which is continuously injecting at a constant rate. Nobody is monitoring that the injection or the separation efficiency is achieved by how much of injection of chemical that is there. And these chemicals, by the way, are super expensive. So if we are able to optimize the rate of consumption of these chemicals, we'll be able to attack the cost of operations and OPEX can be brought down. Now, how can we achieve this? So, of course, we'll need real-time data of what is the rate of injection, what is the concentration of injection of that chemical, be it demulsifier, be it de-oiler, be it H2S scavenger, whatever is the chemical. And what is the end output in terms of separation efficiency or the sulfur content of the emitted gases, right? We have to monitor that as well, along with the real-time data of flow of the substance which is flowing into the pipelines, the temperature, the pressure. Based on these inputs, the model can, in the real time, adjust what should be the ideal injection rate, and then give a control loop. Through a control loop, it can give the command back to the chemical injection pump that it can alter the concentration and the volume or the frequency at which the chemical is being injected. This is another very valuable use case. We have seen this in case of Petronas. And this use case has been implemented there. During pegging and without pegging, the requirement of chemical that is required for separation is very different. So it needs to be adjusted based on the event that has happened prior to chemical injection. Similarly, if we, instead of doing a continuous chemical injection, if we break it into batches, then we can also attain the similar efficiency in separation at a lower cost of chemical consumption. So these are some of the practical use cases which we have seen. Coming to the next one, this is also a very pertinent problem for, again, upstream and downstream industry. In case of pipeline, in energy industry, we all know that there is huge network of pipelines. There are trunk pipelines, there are spur pipelines, there are long distance pipelines which are carrying crude from point A to refineries. Now, how do we measure corrosion? All these pipelines are susceptible to corrosion. There is a continuous corrosion happening. Typically, how do we monitor it? We monitor it at a very distant frequency through intrusions, which is not a very scalable and very efficient way of doing it. Again, we have come up with models which are possible, which enable us to monitor inline corrosion in real time, and it can give you graphs of what has been the real time corrosion as well as the cumulative corrosion in the pipeline over a time duration, let's say 1 week, 1 month, or 1 year. And by this particular solution, we are able to identify which are the risk points across the pipeline of the length of 60-70 kilometers and take corrective actions. We can also integrate these corrosion protection models with existing pipeline integrity management system, where it brings up the comprehensive risk-based maintenance picture for this asset of pipeline or network of pipelines. The benefits that have been achieved is in reduction of pipeline maintenance cost by 15 to 20%, and the probability of repairs required in the pipelines has also gone down by 40%. Of course, once the pipelines are up, the uptime, there's availability of pipelines, then the production is also not hampered. Ultimately, it's a production gain also. So let me summarize. These are 4 or 5 workflows or analytics algorithms that I've spoken about. This can also be taken to wax or sand modeling. It can be taken to real-time process optimization. And there are many more such solutions which we can talk at length. But the end benefit is to achieve industry-leading production growth, reduce cost of operations, which is OPEX and CAPEX reduction. And ultimately, if you increase the revenue, reduce the cost, you are increasing your margins. So just to put a number there in front of all of you, we have seen that there is an EBITDA uplift of almost 2 to 3% in all of these companies that we have worked with. And we are happy to scale it up to other companies as well. There was a small case study which I can take up later, It is an Indian case study, and we have also a global case study. Um, yeah, so all good. This is all from my end. We'll take questions towards the end. Thanks.
Thank you, Shreyansh. Next speaker is Srivardhan Grandhi, Senior Manager from Engineers India Limited. Over to Srivardhan.
Good afternoon. I thank IEW and my coaches and particularly my organization EIL for giving me opportunity to present our views on my topic, NGRT heater. It's particularly AI and IoT based tool for optimum and safe fired heater operations. So it is really context set the context for the operation excellence, because this software not only helps us for operational excellence in terms of efficiency improvement, but also for the safe operations of fire heaters. So that is another important area we work on. And as EIL, we are having experience of design of various units. We have very large data bank of various service providers. We participate in various troubleshooting. So that brings us an idea of, okay, why not bring some solution in the area of fire heaters, which are very critical in operation. So yeah, so I'll just cover some ideas of fire heater optimization and some success stories, and because we already implemented in some of the refineries. And so what is NGRT heater? Like it's a short form of ENG means Engineers India, RT means real time, and HTR stands for heater. So it's a real time optimization software for the fire heater performance. And we call fire heaters as the hot workhorse for the process industries, because we know almost 50% of the total energy consumption goes in the refinery goes for fire heaters. So with I have participated in various energy audits in India and abroad. So we do energy audits, and one important critical area is fire heaters. So based on the operating data, we give some suggestions. But the thing is, by the time they are going to implement it, the data is not relevant. So there comes the importance of AI tools. Based on the present operating scenario, you should be able to give suggestions. And also fire heater operations, there are various old process units, and also sometimes units must have design when the unit is energy is cheap, and because of expansions you must be having multiple units. So there are various decision makings for which you go for energy audits or any licensor. So this software limits all these requirements. Okay, so that gives some brief background of what is the fire heater energy analysis. What are the energy that goes into the fire heater is almost distributed in what the pie chart says, almost 60% for the all radiant heater. And as the technologies are going up, we are trying to reduce the stack losses, because we are introducing various energy recovery systems like cast air preheaters, glass air preheaters, etc. So all these things should be considered while we are optimizing our fire heater. So there are various opportunities in fire heater operations, like the most critical one is the fuel sulfur and fuel changeovers, because based on the fuel availability, you may go for mixed fuel in most of the cases, maybe oil, fuel gas, natural gas, and accordingly, excess air should be controlled in it. And also, most of the times there are various process variations, because yes, in India we depend on imported crude. Based on the crude availability, we do operate our plants. So thus there are various process variations, and it is dynamic in nature. And another very important area is the ambient conditions. Like India, we have different typical ambient conditions. Maybe if we talk in the North India, the temperatures may vary drastically for even in the morning and night. So those are all things should be considered while we are using an optimization technique. So with that background, we developed this NGRT heater. It's a trademark one. We have a patent filed in this. So it covers these fire heater, because after prolonged operation there are changes, deterioration, and they can lead to unsafe operations. Like during our audits, we have seen that because of the data that they see in their DCS, they must be feeling that the fire heater is safe. But we were astonished by going there physically, near the fire heater. We found that there's so much of kind of unhealthy situation inside the fire heater, and in no time it may call for maintenance. So having these kind of softwares will help us to save ourselves from those situations. And as I mentioned, we are expertized in providing the solution, and we are the leading energy transition, service provider particularly. So with that experience, with know-how of more than 400 fire heaters, we thought of, we developed this AI-based tool, because we have inbuilt so many AI data banks inside this, both from the design side as well as on the operating side. And what are all the things, in short, we can understand what kind of inputs that are required, the fuel specification, flow rate, exercise that you are already keeping, damper settings, fan capacity, stack temperature, ambient conditions as I mentioned, and some other permissives, because based on the design, you must be using some kind of constraints in your equipment in your fire heater. So those all things will be taken, and based on that we'll get an output. What is that excess air that should be actually kept? What are the damper settings that has to be kept? And then we'll be getting the efficiency improvement, and what is the optimized stack temperature, and sometimes even we get what is the preventive maintenance steps that are needed. And as I mentioned, if there is any hardware limitation in our system, like for example in India, what is happening with the natural gas coming up in a large level. So now people are, in refineries are thinking to shift to natural gas. So in this case, you know what are the limitations that are there. So it's like a doctor for you. You need not go for outside, any consultant for understanding those kind of limitations. So what are the things? So we'll be modulating parameters that are required, and based on the current situation, you'll be getting the improved efficiency also, and also what are the what things to be needed for protecting the equipment, and also as I mentioned, hardware limitations are also covered. So by how it can be done? By changing simply the flue gas exit temperature, excess air limits, damper settings of both stack and APH, etc. So this is a web-based platform, plug and play. Actually, when I say plug and play, a few modifications may be required based on the fire data, because it is very critical of nature. So it is a very user-friendly platform wherein the operator can feed those details. And though we mention it as a real time, there is a catch here, because as we are aware in the previous session itself, there is a power failure, and that's the reason we don't want to keep it as real time. It's only real time in taking the data but not implementing it. We kept a platform wherein the operator can check what the data is going inside. He can adapt the data and then accordingly go for optimization. Yes, we can provide a direct optimizer, that's not an issue, but we felt because it is a critical equipment, it should be kept with the user in interface before it goes for an optimization section. And this is a kind of a dashboard, simply just to give a rough initial idea of what exactly the parameters that were given and what are the set points and actions that are needed. And in the same output card, we'll be knowing what are all the potential benefits in terms of, what are the amount that is saved, what is the efficiency gain that we got, and also in cases where you want to know what are all the carbon emission reduction, because that is what right now is a buzzword. So those are all details are there, and the warnings that are there is also provided. And yes, this output card can be modified with respect to the requirement of the industry which goes for. So these are some snapshots of the, we call it a green signature of the software at different refineries, one located in South India, one located in North India. And in these refinery, they could able to immediately implement the suggestions that is given. And we, because we go for the field checks, how the things are happening, and then we could able to see that it is very, I mean, good. Similarly, in North India also, the results are very much acceptable by the refiners. And we got some certificate of success. And we were like one of the finalists in the Scotch Award also. And we got the EL award, internal award. It was a good thing for our team, encouragement for our team. And coming to the benefits, potential benefits, there are huge. So we know that by 1% increase in efficiency, it can almost save around 2,200 tons per annum of fuel saving, which goes to be around 6 crores. So it is only about 1% increase in efficiency. So we try to keep a cumulative ballpark. If we are going to implement this software in all the Indian refineries, in the next slides I'll be providing that. So we covered only the major large fire heaters like the crude heater, vacuum heater like that, and a typical duty in that, and accordingly what is the fuel saved, and as well as the CO2 reduction in it. And the key takeaways and the way forward, it's a user-friendly, innovative, economically viable tool. It's a kind of a cloud-based, have AI inbuilt into it. And yes, if there are any critical locations where the data has to be taken, we have to go for IoT-based sensors, and that can able to give proper data into the system, because we know garbage in is garbage out. And it is a plug and play web-based dashboard for saving your fuel as well as the asset, which is very important. And it's based on the fire heater design experience and troubleshooting, as I mentioned. And it's a energy saving and GHG emission reduction opportunity, because as I mentioned, almost 50% of the energy consumed in the refineries go for fire heater. So we really suggest all refineries to think about this solution, because they are looking for opportunities for reduction of their energy, and they want to go for low carbon arena. That means net zero. So this is one good opportunity for them to look at for achieving their net zero targets. So another important area, as I mentioned, it is increasing the asset reliability, availability, which is very critical, but because we have seen in the past, there are cases of fire heater failure, which is catastrophic in terms of manpower loss as well as the production loss. So that is very important area, because we have to take care of our fellow colleagues. And it is applicable and reliable across industries, not only in refineries, but also in various other industries. We are exploring even the steel sector, and petrochemicals are yes, and many other such industries, because it can be deployed easily, and it can be used for understanding the debottlenecking of capacity upgradation and various monetary and qualitative benefits in terms of what are the units the user are looking for. And with this, I thank the organizers for giving me this opportunity, and I'm ready for any questions. Thank you.
Thank you, Srivardhan. It's a good session which is completed 1 minute ahead. Next session is by Chakravarthy B S K, Chief Manager from Hindustan Petroleum Corporation Limited.
Good evening. Thank you, chairpersons, for introducing the topic of the session. And thank you all the earlier speakers who have given very good insights into using artificial intelligence and digital technology into upstream and downstream part of oil and gas industry. My topic is to present you a safe and trouble-free operation of refining operation which involves storage of petroleum products. It is a paradigm shift from what we have earlier discussed. It is basically the core framework which supports operational excellence in a refinery or a place where we store petroleum products. As you are aware, this is the business process overview of a typical refinery where we receive crude receipts, store it in crude tanks, and the refining process starts. And then we store the other products which are intermediate or the final products in storage tanks and dispatch it for the end users. Now here I would request you to look at the 2 points where the petroleum products are stored. One is at the crude oil stage before refining, and after refining we are storing these in the refinery or at various other locations. As a ballpark figure, we are storing around 300 plus locations across India where terminals and depots are there, and plus 20 refineries we are storing these products. So the risks involved are huge. The risks associated with storing these petroleum products and managing these risks are huge. It has its own set of challenges, and how do we manage that? So the risk basically can be categorized into 4 types. These are mainly environment. These environment risks are very minor, but they can have far-leading ramifications, like a single spillage or a leak can contaminate the groundwater and the soil and will have many other problems which are related to statutory and all. Then we come to the community safety. The community within which you operate our business, industry or a refinery, especially, we have to be very careful about the safety of those stakeholders. A simple thing like safety lapse and lack of emergency response can put them at stake. This safety is paramount, and we cannot leave this risk unmanaged. Then we come to the supply chain distribution. Supply chain distribution disruption. As you are aware, a small risk mismanagement can lead to supply chain disruption to stakeholders, retailers, consumers, and we being in the oil and gas sector and specifically a refinery, we are the growth engine of this country and we can't risk that. So we have to see that these supply chain disruptions do not happen. And finally, not the least, brand evaluation. Sometimes lack of maintenance, aging infrastructure, and lack of poor response to a risk can put this at stake. Financial loss is anyway a concern, but majorly the brand image gets beaten. So how do we mitigate these risks? These risks, when a couple of tanks are shown here, these risks when a couple of tanks are manageable, but when we are managing a huge tank farm having hundreds of tanks, really these risks get multifold and multiplied. So we need a process. And that process, what are the requirements of the process? This process needs to be preventive. To prevent such a failure to happen, it cannot be corrective. Second thing, the design parameter of this process should be such that the failure event should never happen. How do we do that? So we at Vishak Refinery have designed a process and we are following it, and it is called Safe and Trouble-Free Operation Warranty. This is the buzzword for us, and it is simply an assurance to the management that we will operate the equipment under safe custody and reliable operation. The key parameters of safe and trouble-free operation, I will go in the next slide, but here you see the logo. This logo or the insignia is the logo on all of our tanks, giving 100% reliability for a period of 10 years. The key parameter is it demands warranty for turnaround maintenance. As you know, when we take an equipment for turnaround maintenance, it is expected to deliver 100% of its efficiency for a period that is warranted. Like any other appliance we buy, we obviously invest in an asset which is reliable, and we check that for reliability from time to time. So we invest in an asset which delivers the said performance. Similarly, we have implemented this system for a tank. It demands warranty from all the stakeholders whenever it goes for turnaround maintenance. And this logo is printed on all of our tanks. this is a symbol which develops a value system. It's like a brand affiliation. We love the brand affiliation. We affiliate with the brand so that it's a quality culture. It sets up the quality culture, and all the teams that are handling this activity have an affiliation to the system and the process. This is definitely a preventive process because that's the only window we can drive this process. There's no other window we get when a tank is being operated. So it's definitely a preventive process. How do we operate? How do we drive this process during the preventive and as a preventive process during the outage? In my next slide, I'll be explaining. It also ensures deliberate engagement in learning from past experiences. All our stakeholders deliberately study the performance of the tank for the period that it is under operation, and then those learnings are compiled, and we are taking all those requirements that are required to maintain high reliability of the tank, and this is done during the outage of the tank. Now we'll have a look at the stakeholders: mechanical integrity and reliability, electrical reliability, process safety, instrumentation reliability, operations, environmental standards, and occupational safety. All these are the stakeholders, all the different teams come together and finally deliver a product called STFO. This is weaving the combined interdependencies and the competencies onto a common platform and delivering a high reliability product. And the product here is STFO, safe, trouble-free operation of the tank. Here, normally, our head turnaround maintenance is a central coordinator for this process, and he sees that we are on track to deliver the high reliable product. In any system, for a process to function, there has to be an ecosystem, and the ecosystem provides the enablers so that the process thrives and evolves and develops. Here also we have some enablers. First, advanced entity for integrity assessment. Our inspection does this and details the repairs that have to be carried out. 100% we are replacing the tank bottoms, shells as required and as recommended by the inspection teams. And managing change and improvements. From time to time, we are getting some improvements that are to be implemented. Maybe like Ministry of Environment is giving those suggestions or the laws. And somewhere we have to improve the storage life of the tank. So we might improve the painting system also. All these changes, whether it is process or maintenance, we implement these changes and compile them, and we are ready during the turnaround of the tank. And there is a high thrust internal process meeting, which we call as HTIP meetings. These are chaired none other than the head turnaround maintenance every month. He sees that we are on track to deliver the high reliable product whenever we go for a turnaround of the tank. Coming to the warranty checks that are carried out, first we come to process safety. The limits of safe operating envelope are checked, and the list of hardware that is required to indicate those limits are checked and in the field and on the DCS. Then we come to occupational safety. For operating the tank, any requirements as simple as staircases, access ladders, pathways, firefighting systems, foam systems, everything is checked and occupational safety is ensured. Then we come to environmental standards. Environmental compliances are checked, and the design systems, whether they are in place to take care of the effluents during normal operation and the upset situations, are also checked. And coming to mechanical integrity, design conformity is once again checked, and the integrity assessment is done through NDTs. And any improvements, like I was saying, painting, roof seals, armored hoses, these improvements are also taken up during the TA window, and before the TA window, all these are listed out as an STFO process. Coming to electrical and instrumentation reliability, IR value checks for all cables are being done, and API RP 545 lightning protection jobs, earth pit integrity is checked, and all the PTs, LTs are thoroughly checked, and new LTs and PTs are installed. Finally, after all the above checks and verifications are done, equipment safe custody and operation is assured by the operating team. Here the operating team signs an assurance to the management that whatever is required to operate the tank is available, all the checks have been done, and we are going to operate it with safe custody and reliability. These are the few records that I will be showing. This is the cover page of our STFO warranty protocol. Basically, it implies the equipment number, the tank number, and the service and the warranty period. Here, the warranty is for 10 years. The TA that is taken, the dates, etc. Then we go to the 8 reliabilities that I was saying. This is the index page. Further details are there, but this is the index page where the 8 reliabilities are listed. For each of the reliability, the final division head has to sign and submit. And this is an actual photograph of a tank on which the logo is painted, and the photograph itself is part of this document before handing it over to the operations. So the journey so far, STFO has become a mantra for us at VR, and it is implemented in 2014, and we have given this assurance of safe and reliable operation for 92 storage tanks and mounted bullets, and the ultimate product we received is improved reliability and availability of our equipment, that is storage tanks. And hence, going forward, this year we are going to implement this for pipelines as well. So to summarize, the benefits of STFO are 100% assurance that we are giving to our management, and the trust within the teams which we operate. We have a lot of trust, and the risk has been assessed and mitigated. All the risks have been assessed and mitigated, and this is a single record for turnaround. And this record, here you can see the smiles and the assurances. Here our head maintenance is giving this document. This is part of a small custom. We give it to our operations head. And finally, I would like to say one thing. We all work for a flawless performance of our equipment, low maintenance, high reliability, and what do we get from that? We get only one thing, and that is peace of mind, and STFO gives us that. Thank you.
Thank you, gentlemen, for very wonderful presentations and insightful, as well as with use cases highlighting how technology is enabling the organizations to achieve the operational excellence. Varied chapters, all 4 sessions, different sessions. While Shailesh actually presented how the technology is helping, along with the domain knowledge, customers with predictive as well as prescriptive analysis to drive the increased operationally reliability. That's a good session. And Shreyansh's presentation was totally on a different topic. It is mainly on the real-time production monitoring. And it involves all the technologies. Like we have seen how we use the IoT, data analytics, predictive process modeling and all, mainly to drive the productivity improvement for the plants. And Srivardhan presented a new indigenous tool. Again, it's quite good to see something is developed in-house based on the AI technology, and mainly to monitor the heater in refineries for the improving the operating efficiency. That's quite good. And the final one, Chakravarthy has presented totally a different topic, but very relevant with respect to operational excellence because it's considered more of safety. The stringent process and guidelines basically to operate and maintain the tanks. So overall, I think all the very wonderful topics, sessions by all the 4. I thank you for this insightful sessions.